Hi guys, today we're doing climbing stairs. So we're climbing a staircase and it takes n steps to reach the top. They say each time we can either climb 1 or 2 steps, and how many distinct ways can we climb to the top? So in example 1, we're given input n equals 2 and we would output 2 because there are 2 ways to climb to the top. We can either start from the bottom and take 1 step to get to step 1 and then another step to get to step 2, or we can start from the bottom and just directly take 2 steps to get to step 2. So in example 2, we're given input n equals 3, and then we would output 3 because there are 3 distinct ways to climb to the top. So we can either start from the bottom and take 1 step at a time 3 times. We can take 1 step and then 2 steps, or we can take 2 steps and then 1 step. So in this one, we're going to want to use dynamic programming to store the number of distinct ways to climb to a certain step. So if we want to define our recurrences, so we can start by defining like what is the problem we're trying to solve, right? So we can say like opt at I, and when defining this, so like we want to keep track of all of the variables that we need in order to solve this problem, right? So like I in this case is going to be whatever step we are currently at, right? And then the thing we're trying to get here is the number of distinct ways we can climb to the top. So then opt of I will be the number of distinct ways to climb to step. We can say like, yeah, to step I, right? And this is going to be like from steps 0 to I. Okay, and then we need to define our base cases. So I think it'll be more clear if I show it with an example actually. So let's say let's just take the first example, n equals 2, and then I'll show what our opt array might look like. So 0, 1, 2. So we're gonna have 2 indices, right? 0, like these indices are each representing each of the steps that we are currently at. And so as we can see, right, opt at I, if we're looping through this array, then, or like from 0 to n or whatever, right, then I is, which is whatever index we're at, whatever number we are at between 0 and n, is the step that we are currently at. So opt at like 1 would be the number of distinct ways to climb to step 1, right? So at 0, then we know that this is going to be 1 because there's only one way to get to 0, which is not taking any steps. Okay, and then at step 1, then there's also only one way to climb to step 1. So this is going to be a 1, right? Because we can only take 1 step to get to step 1. Then at step 2, we can do what they said here, right? So we can either take 1 step from 0 to get to 1 and then another step to get to 2, or we can start from 0 and just directly take 2 steps to get to 2. So if we add those up, then that's going to be 2 steps, right? So if we think about that, then our base case is going to be opt at 0 is 1 and opt at 1 is 1, right? Because these were our first 2 cases that don't depend on anything else from before. Like no matter what, these are just what it's going to be. And then now we can start to define our recurrence. So our recurrence, if we think about like at every step I, we have 2 options, right? We can either take 1 step, or not like take 1 step, but like if we think 1 step back, right, we could either have gotten there from 1 step back, so like at step 2, we could have either gotten to step 2 from step 1 or from step 0, right, depending on if we took 1 step or 2 steps to get here. So we can say opt at I is going to be, and the 2 options, right, so if we got here from step 1, then that's going to be opt of I minus 1. And if we got here from took 2 steps to get here and got here from step 0, then that's going to be I minus 2, because we got there from 2 indices ago. Does that make sense? So, and then because we're just like adding these up to get the number of, because we want the number of distinct ways, which is what we're tracking in here. So we can just go ahead and directly add these just like that. Okay. So that's basically it. Now we just need to set up the actual problem. So we can start by defining our opt array. And then we're going to make this size n plus 1. Because if you see here, n was 2 in this example. But like we also need an index for 0 to cover our base cases, because there was no, because like we need to be able to start from step 0, right? Like, because that's the actual bottom of the stairs where there's no step yet. So, but then we also need to be able to get all the way to the top, which is n. So we're going to make this size n plus 1 to account for that, right? And then we just need to start by defining our base cases. So opt of 0 is going to be 1, opt of 1 is going to be 1, and then now we can start filling out our actual table. So we're going to say for I equals 2. We're going to start this at 2 because remember, like 0 and 1 were our base cases, so we'll just start at the 1 right after that. So I is less than or equal to n, because we're going all the way up to n here in this case in the table. I plus plus. And then we're just going to directly be able to plug in this recurrence. So just like that. And then our answer is going to be in the last index in the array. So we can just go ahead and return that. So we'll just say return opt.n, and that should be it. So let's test this out. All right. So our time complexity is going to be O of n, where n is literally just this number n, because we need to do one pass through for all the way from 0 to n to calculate all of the values in the table. And then our space complexity is also going to be O of n with the same n, and that's because we need this 1D opt array to be able to store all of the distinct ways to climb to step n. So that is it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!